We will be discussing in this lecture is registration. That is how a mobile node is getting registered with the HA. Okay. After receiving COA, that is care of address, the mobile node has to register with the HA, home address. So the main purpose of the registration is to inform the HA, home agent. HA stands for home agent. Inform the HA about the current location for correct communication. So the registration can be done in two ways. Registration can be done in two ways. The first method is followed if the COA is at FA. The first method is followed if the COA is at FA. And the second method will be followed if the COA is a co-located COA. So this method will be followed if the COA, that is care of address, is located at the foreign agent. And this method will be followed if COA is a co-located COA. If the COA is at FA, then registration will be done something like this. The mobile node first sends a registration request to the COA, which is located in the FA, okay, and which in turn will forward the request to HA, home agent, okay. This the mobile node first places a request to the COA, which is located in FA and foreign agent, and the foreign agent will forward the request to the home agent. The home agent now sets up a mobility binding. The home agent will now set up a mobility binding which consists of mobile node's home IP address and current COA. Okay, this mobility binding includes the mobile node's home IP address and the current COA. Additionally, the mobile binding also contains the lifetime of the registration during the which is negotiated during the registration process. Okay, so it also contains the lifetime of the registration, how long the registration is valid. The registration will expire once the lifetime is uh, after the lifetime, and it will be deleted. Okay, so M1 mobile node should re-register before expiration. Okay, still if it is continuing in the same network, then it should re-register before it expires. So this is required to avoid mobility bindings which are no longer used. Okay, so let us see the diagram. So for clarity, so this is the diagram. The diagram in the left side. This represents how the mobile node is registering with a home agent when the COA is located in the FA, in the foreign agent. So first the mobile node is placing a request to COA which is located in the FA. Then FA forwards this request to HA, home agent, and then the mobility binding happens, which includes mobile node's home IP address and the current COA. So during this time, the registration lifetime will also be fixed. So once the registration lifetime is over, the once the registration uh, lifetime uh, is completed, the okay registration lifetime expires automatically after the lifetime. Okay, so registration lifetime will expire. Registration will expire. The registration itself will expire once the lifetime is over. So the mobile node should re-register before the lifetime is getting expired. Okay. So this is the process for registration if the, the COA is located in the FA. Now let us see how the registration will be done if the COA is co-located. If the COA is co-located, the COA is co-located, registration can be much simpler. The M1 now can send a request directly to HA, and HA also can communicate directly back to the mobile node. So, so this way the registration procedure for M1s. So normally this is done when the M1 is returned to the home network. Okay. So here they register directly with the home agent. However, if the mobile node received an agent advertisement from the FA, then it should register via the FA if the orbit is set in the advertisement. Okay. So, so let us see the diagram for how the registration is done if the COA is co-located. This is the diagram. If the COA is co-located, then the M1 can register directly with the HA, and HA can also respond directly back to the mobile node. Okay. So then what we'll be discussing is, for registration purpose, UDP packets are used. UDP packets are used for registration request. So, so let us see that packet. So this is the uh, registration request packet. Okay, and here we can see UDP packets are used for registration request. The source IP address of the packet is the M1. The IP address of M1 will be the mobile node will be the source IP address, and the destination IP address will be either FA or HA, depending on whether the COA is located in FA or co-located. Okay. If the COA is co-located, then the destination address will be the address of that particular co-located address. If the COA is located, so the destination address will be either FA or HA, depending on the location of the COA. Okay? And the UDP destination port is set to 434. UDP destination port is set to 434. UDP is used because of lower overheads and better performance compared to TCP in wireless networks. Okay, so UDP is used because of lower overhead and better performance than when compared to the other fields which were the other fields or a type will be set to 1 for registration request and S bit, and there is something called as S S bit will be set to home agent. Okay, so 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 with S bit and M1 can specify if a HA to if a HA should retain prior mobility bindings or not. If S bit is set, then the home agent should retain the prior mobility binding. Okay. If it is not set, then it need not maintain the prior mobility bindings. So previously we discussed mobility binding. It includes mm, the original IP address, the home IP address of the mobile node, and also the current COA. And there is something called as B bit, which indicates that an M1 also want to receive the broadcast packet which is received by the HA. Okay, whatever the broadcast packet that is sent to the HA, M1 also want that. That can be represented through B bit, and there is a D bit. There is a D bit which is for decapsulation at the tunnel endpoint. This will be set if it is a co-located COA. Okay. And there are M and G bits which is used for minimal encapsulation, and there is a T bit which represents reverse tunneling, that we will discuss later. Okay, we have not yet discussed reverse tunneling. We'll see in this session. And there are OR and X bit which are set to zeros. Okay, so these are the bits associated with registration request. And also we have some more bits lifetime which represents the validity of the registration in seconds. It represents the validity of registration in seconds. A value of 0 indicates deregistration. If lifetime value is 0, then it means it is deregistration. All bits indicates infinity. Okay, and the home address is the fixed IP address of the mobile node. Home address is the fixed IP address of the mobile node. Home agent is the IP address of the HA. Home agent is the IP address of the HA, and COA represents the tunnel endpoint. COA represents the tunnel endpoint. Okay, so this is about the registration request packet. Similarly, if you say registration reply, so there are two packets: registration request and registration reply. Registration reply also a UDP packet with type 3. For registration request, the type value will be 1, whereas for registration reply, the type value will be 3. And it has a code indicating the result of registration request. There's a code indicating the result of registration request. So these are the possible codes of registration result of registration request. 0 represents registration is successful. Okay, so these are the two cases where registrations are successful: 0 and 1. 0 represents registration is accepted. 1 represents registration is accepted, but simultaneous mobility bindings unsupported. Registration is accepted, but mobility bindings are not supported. Okay? And registration is denied by FA under the following reasons with their respective code: administratively prohibited, insufficient resources, whatever it may be. Registration denied by HA because of these reasons. Okay, so these are the possible outcomes of registration request. So this is the registration. So this is the format of registration reply packet. Type is equal to 3. You can see here. So again here also the lifetime field indicates how many seconds the registration is valid if it was successful. Okay? And home address and home agent are the addresses of the mobile node and home agent. Okay? So, yeah, so that's it about this particular topic, registration. So what we have discussed is once the COA uh, once the COA is received, the mobile node has to register with the HA. After receiving the COA, the mobile node should register with the HA, and the main purpose of registration is so that the HA can locate the mobile node and it can forward the packets. And registration can be done in two ways. If the COA is at FA, then there is one style of registration. If the COA is co-located, then there is another style of registration. And there are two packets. One is registration request, the other one is registration reply. Both are UDP packets. What are those packets? What are the various fields, and what are the various addresses? Those things we have discussed. And how registration request is done. How registration is done for uh, when uh, when COA is in FA, and how registration is done when COA is co-located. That also we have discussed. If the COA is in FA, then the registration will be done something like this. The request goes from M1 to FA and then FA to HA, and then mobility binding takes place, and then again reply from HA to FA and FA to M1. But But if it is a co-located COA, then the registration directly happens from M1 to HA. Similarly, again reply back from HA to M1. So yeah, in case of a registration request packet, yeah, these are the explanation of the various flags. So S represents simultaneous bindings, B represents broadcast datagrams, and D represents decapsulation by mobile load. M represents minimal encapsulation, G represents GRE encapsulation, and R is equal to 0, which is generally ignored, it is not used, and T represents reverse tunneling, and X is also 0, which is ignored. Okay, so basically S bit is used uh, if with S bit, and M1 can specify if it wants the HA to retain prior mobility settings. Okay, and the B bit is generally indicates that an M1 also want to receive the broadcast packet that was received by HA. Okay. And D bit is used to indicate whether decapsulation should be done at the tunnel endpoint or not. This will be done if the COA is a co-located COA, then the D will be set. And M and G represents minimal encapsulation and generic routing generic routing encapsulation. T represents reverse channeling, and R and X are generally set to zeros. Okay. So that's it about this part topic, registration. Fine. So let us stop here. Thank you.